Hi guys, BuildZoid here, and today we're going to be taking a look at another DDR5-8000 setup with Ryzen 9000, this time on the Asrock X870E Taichi Lite motherboard, which I bought, so a big thank you to the channel supporters for making the purchase of the motherboard possible. If you'd like to support the channel, there are links in the description that you could check out. That would be very much appreciated. The memory kit that I'm using is a G.skill Trident Z5 RGB Neo kit, which was provided by G.skill, so a big thank you to them for sending over the memory for testing. It's a 2x24GB 8000 CL40 EXPO kit, so it uses Hynix 24GB MDI memory chips in a single rank configuration. And I'm happy to say that the EXPO profile on this kit with this motherboard on the BIOS version that I'm currently using works great. Yeah, like, so, yeah, like, well, anyway, we'll get to that later. And then the CPU is the Ryzen 7 9700X that I've been using for most of, well, actually all of the DDR5-8000 videos so far. And the reason I'm just sticking to the CPU is I know for a fact that it does DDR5-8000, and this is the first time that I'm doing DDR5-8000 on this motherboard, so I wanted to minimize the number of variables that I would potentially have to deal with. So this is sort of like, to me, this is basically a validation run, more so than an actual, like, I had to do very difficult memory overclocking stuff, because I didn't. The EXPO profile on this BIOS version just worked, and then I did some basic, like, timing adjustments to get some more performance out of it. As you can see, I do have a fan for cooling the memory sticks. In this scenario, I think it's really overkill because the memory, like the EXPO profile is 1.4 volts, and I didn't bother to touch the voltages yet. Because a lot of the timing adjustments that, like, well, all of the sub-timing adjustments really don't need any extra voltage. So yeah, the extra memory cooling probably isn't that necessary in this scenario, because the memory kit's just running at 1.4 volts. Though, unfortunately, and I think this is an issue with this motherboard, I don't have memory temperature sensors in hardware info. Like, they're just not there. So I'm assuming this motherboard is, like, blocking access to the temperature sensors on the memory sticks. So that's kind of annoying. Yeah. Anyway, so the thing with the fan is, though, like, if you point a fan at the memory, you don't really have to worry about the memory temperatures, because especially on an open air test bench like this, that fan is just massive overkill, especially in the scenario of rather low voltage, and then also the fact that this is a 9700X, so it can't even stress the memory that hard anyway, because it doesn't, like, it's a Ryzen CPU, it just doesn't have that much memory bandwidth. And then the single CCD ones have even less memory bandwidth than the dual CCD ones because they have a write bandwidth limit, which usually isn't much of a concern, but for memory stress testing, it does actually affect the memory temperatures. Like, you do get slightly higher memory temperatures on the dual CCD chips, which are still lower temperatures than what you get with Intel CPUs for memory stress testing. But anyway, like, a 9700X is basically a 9800X 3D, and the 9800X 3D is kind of probably the CPU most people care about, so I don't think this is that unrealistic, right? If you have a 9800X 3D, you have the exact same write and read bandwidth limitations as a 9700X. So, yeah, though I am kind of annoyed that I don't have temperature sensors for the memory sticks. Anyway, as you can see, no errors. Ran Karhu for 18 hours, Y-Cruncher large FFTs for 10 hours, I mean, not Y-Cruncher, Prime 95 large FFTs for 10 hours, and Y-Cruncher VT3 for just under 3 hours. So all of those tests passed. Yeah, I think at this point we'll just go into the BIOS and take a look at things there, because I don't really, like, yeah, like, the stress tests all passed, and unfortunately we can't even check the memory temperatures. So that's kind of annoying. Though I will point out, I did test with the increased power limits. So the CPU did max out at 142 watts. Yeah, because Prime 95 and Y-Cruncher are very power-hungry workloads. And also, if you stressed, like, I'm not sure that it would be valid to, like, technically, like, especially Prime 95 and Y-Cruncher will actually run slower if you have a CPU power limit, which will not make them as stressful as if you remove the power limits. So anyway, at this point, let's go take a look into the BIOS. Now this board boots very quickly with its memory context restore enabled. Also, you'll hopefully notice that like power down is disabled, and that's just standard on the latest AGSAs. Yeah, I think this might be the fastest reboot I've seen with 9000 series so far. So anyway, here we are in the BIOS. And I will admit that like one of the reasons I specifically went with this, well, there's just sort of two reasons why I went with the 2x24GB G.skill kit. One, I haven't tested it yet. It hasn't been featured in a video, so, you know, need to make some content with it. Two, I've heard that Asrock had, like, especially at launch, I don't know if it's been fixed yet, but at launch, Asrock seemingly had issues with high voltage mode on their AM5 on their, like, X870 boards. And this memory kit doesn't need high voltage mode, right? Because it's just a 1.4 volt EXPO. Whereas, like, say the 8000 CL38 kit, that is a 1.45 volt kit, so that would actually need high voltage mode working. And, I mean, I am going to test that anyway, but for the first setup, I wanted to avoid any, you know, extra complications if possible. So, yeah. Anyway, so just 1.4 volts across the board for everything. And, yeah, so... Like, it really is just like I turned on EXPO and it just kind of worked, and then I tightened the timings. Asrock is actually kind of... Well, Asrock is the first manufacturer I've seen to not just set the SoC voltage straight to 1.3 volts when you turn EXPO on. They set it to 1.2, which for 2-to-1 mode is still unnecessarily high. There's really no reason to set it to... Like, I'm running it at 1.05 because in 2-to-1 mode, your UCLK is so low that you don't need a ton of SoC voltage. But it's better than like MSI and Asus, who both default straight to 1.3 as soon as you turn on EXPO, which just massively increases the CPU's idle power consumption. Not that I care that much about it, but then in certain like actual workloads, it starts eating into the CPU's power budget. So I do kind of appreciate that Asrock isn't all hooray high voltage on the SoC power rail. Because, yeah, most other manufacturers just, like, auto that straight to 1.3 volts as soon as you turn on any kind of EXPO profile, even an 8000 2-to-1 mode, where it really, really isn't necessary to have a ton of SoC voltage. Other than that, I've left the FCLK at 2000, because that synchronizes with the UCLK at 2000, Oh yeah, and for the power limit, I just turned on the TDP to 105 watt thing. Now let's take a look at the memory settings. Now this is one place I do actually have complaints for Asrock, which is there is no TRCDWR register. On this BIOS version, I'm relatively certain it should be available. Yeah, because we're on... Like, this is the latest BIOS version. It doesn't say what AGSA this is, which is kind of annoying. But, basically... on MSI BIOSes, and I think Asus BIOSes as well, I haven't checked Gigabyte yet, AMD has, and like, AMD has exposed the TRCDWR register. Asrock doesn't have it available in their BIOS, and I haven't managed to find it even, I mean, I didn't dig that hard through the AMD overclocking menu, but it should be in, like, timing configuration, and then if you set this to enable, yeah, wait, nope. SPD timings, yeah. So there we just have TRCD. So, like, I had a bit of a look around, and I just couldn't find the TRCDWR timing. Not a huge deal, but, you know, I hope they add it soon, because it's just like something more that you can do to get a bit more performance out of the memory. And so it's kind of annoying that it's not available, because with basically, at least with Hynix memory sticks, you can usually set TRCDWR to like 16 and it just works. Actually, you can probably set it even lower than that. I just don't see much point, like, pushing it all the way down to 8. Because it is technically just TRCD specifically for write operations, which aren't really that important most of the time. Oh, I did leave wait. Oh, no, I did it backwards. Oh, well. Yeah, because I'm like, I autopiloted, because, again, like, I was on MSI for a while recently, and there you have TRCDWR, TRCDRD, and so it's like, oh, yeah, so that's TRAS, which actually what I wanted to run was this, because this would technically be slightly faster with TRP set to 44 instead of TRAS set to 44. And the reason for that is very, very simple. TRAS is only relevant very shortly after an activate command, whereas TRP is relevant anytime a pre-charge command is sent. So TRAS basically is important if the memory controller is like hopping from one row to the next row constantly, which is kind of not an ideal operating condition. Whereas TRP is like anytime you need a pre-charge command, TRP is relevant. So yeah, I basically set these backwards because it doesn't, like, from a stability perspective, it's not a big deal. But yeah, ideally, like, I should have had it the other way around. And then TRC set to just the two added together, which is 92, because 48 plus 44 is 92. So yeah. It's what, yeah. Oh well. Anyway, not a big deal, but yeah, just kind of a silly mistake on my part. It's also worth noting that sometimes, like, some memory kits will actually really struggle with low TRAS, especially if you also try to lower TRP, which is, again, you should just prioritize TRP because that's the more frequently used timing. TRAS has like a very specific scenario in which it's relevant, and any other time it just doesn't matter. So, yeah. TWR of 48, which is supposed to be the register limit. I don't know why Asrock says it's minimum at 42. I really wish there was just like some standardized documentation for memory timings, like directly from AMD of like, hey, this is actually what the register bottoms out at. And then when the motherboards, because this is like, for a lot of these timings, it's not consistent across different motherboard vendors. So yeah, anyway, so TWR at 48, because at least on everybody else's motherboards, that's the register limit. So I don't know how Asrock is getting it to 42. TREFI, 65,000. If you don't run a fan on the memory, you might not be able to run the refresh interval this loose. I mean, this long. But usually you can get away with like 50,000 even without a fan. Refresh itself is at 656. This is a little bit on the looser side just because, like, a lot of the time you should be able to even run it at like 640. I just don't see a point in really trying to push it as low as it goes, because at 656, it's already like 1% of your available clock cycles with the refresh interval set to 65,000. So it just isn't going to impact performance that much to set it any lower than this. Yeah, then we have TRFC2 and TRFC same bank, which are set to 69, which is nice because neither of these do anything. These are both like timings that the memory controller doesn't actually use, so you can set them to whatever, which is why I set them to 69, because that seemed like a nice number. Anyway, RTP at 16. This is a little bit on the looser side. They could probably run 12, but again, I wanted like a stable setup without too many issues here. Then TRRDL, TRRDS were at 12 and 8. 24 gigabit MDI very consistently struggles with low TRRDL. So like 10, I would expect to work at like 7600, and then at 8000, it probably needs 12. So I didn't actually test if it won't run 10, but I'd be very surprised if 8 worked. And then TRRDS is the same kind of thing. Like 24 gigabit MDI generally doesn't do super low TRRDs. So that's at 8. TFAW at 32 because TRRDS is at 8, so 8 times 4 is 32. Then we have WTRL at 16, WTRS at 4. This is about as low as these are going to go. read to read SCL at 8, write to write SCL at 8. I didn't check if these would go lower. I've experimented it with that sometimes on other kits that like I've tried 7 or something, and it hasn't worked in the past, so I usually just stop at 8, but yeah, I didn't actually check with this memory kit if it won't go below 8. And then write to read at 6, TRDWR at 18, and that's the end of the settings that we have in here. And that kind of brings up the other issue, which is that, yeah, like Asrock, so on the MSI board, at the bottom of the memory timing section, you have some extra settings for like trying to get the PHY RDLs to match up. Well, I guess it's buried somewhere in the AMD overclocking menu. So that's basically my current main complaint for the Asrock BIOS is that, yeah, this is probably... Wait, no, that's not it. So where did they put that? It might be under Nitro mode? No, I'm not seeing it. Because yeah, on the MSI board, there's a timing, like there's a setting you can adjust that gets the memory controller to try train different round trip delays or read delays or something like that to try get the memory channels to match up with each other. That doesn't always work. Like I've seen some memory kits where it just trains both of them 2 ticks lower and they're still mismatched. So, you know, it's like technically that didn't help. And so on this board, with this kit, it's training 3840. And yeah, I am not seeing any way to try fix that, which is kind of inconvenient. Oh wait, it's here. Yeah, so this one. So fiddling with this. Now the thing is, if you lower it, it might cause instability, but adjusting this can sometimes get the RDLs to match up. So I kind of wish Asrock had that in the main DRAM timing configuration, because that's where MSI has it. I haven't checked where Asus puts it, but this is one thing I really appreciate about MSI's boards, is that sometimes their BIOS is a bit weird, but at least they put all the, they really do try to put all the useful settings into the useful settings part of the BIOS, instead of having you search through the advanced menu. Anyway, so yeah, that's kind of it for the BIOS settings, though I will show the... Like, I want to go into Zen Timings to show you the mismatch in the RDLs. And I guess we could try fix it to see if that... clears up or not. Because the thing is, with the mismatched RDLs, you do get a slight latency penalty for that. So it's like one of those things, like I wouldn't prioritize it, because obviously if you tighten this, then it might cause like instability. But once you have something that's stable, you could try tightening it and then see if that leads to like, if that like doesn't destabilize it. That's kind of the main concern. Speaking of things like destabilizing stuff, I did actually experiment with turning off gear down mode on this board, and that made it very upset. It didn't survive even 13 minutes of Prime 95. Now where's Zen Timings? But that might just need more testing on my part. Anyway, yeah, so you can see T-PHY RDL over here is at 38 on one channel, and the other channel's at 40. And this is pretty typical for most AM5 motherboards on their like default configuration, but it does also vary by memory kit. I have some memory sticks that default to like 36 and 38. And those, I think, are actually a problem, because I've never seen them actually line up to like 36, 36. So... Well, I'm not sure how much of a problem that is. Theoretically, the lower RDLs should lead to like slightly better latency, but then on the flip side, those memory sticks also weren't stable ever. So I'm not really sure what's going on with that. Because it's on like one hand, oh, it's great, it trained like super tight. And then on the other hand, it's like, yeah, it trained super tight and it also doesn't run. So, all right. New training, so we'll start with 1. this should be defaulting to 3 once we're above 6400, and 1 worked for the Tomahawk for getting them aligned, so we'll see if that works here. It might also not train. Also, this board is kind of on the longer end of memory training times. But then once it's trained, like the fast boot works really well. And honestly, like the boards that have really fast training, like they concern me. Because it's just like I don't trust it. That's not to say that I've actually noticed like a real problem with them, but like it's just with DDR5 the whole like, oh, this boots really quickly. That to me just doesn't feel right. Like I know for most people it's like, oh, that's great, it boots really fast, but it's like, yeah, but like what if it's like not training properly and that's why it's booting so fast. And then it's going to be unstable. Mind you, technically you can fiddle with the nitro mode settings to get the training time down. But the obvious downside to that is like you could end up making the stability a lot worse. Anyway, let's see if this trained 3838 this time. Okay, 38 on this channel, and yeah, so that matches so that matches this kit up. So that's cool. Because I have had some memory kits where it'll like go from 3840 to 3638, and there's nothing like you can keep adjusting that setting from like 0 to 1 to 2 to 3, and it just doesn't ever match the two channels to each other. Which is a little bit it's a little bit suboptimal. Though, funnily enough, all the kits that I've had that issue with are also kits that just don't work at DDR5-8000 anyway, so I guess that's like a sign of like you should just give up. If it doesn't want to train matching delays, then it's just not gonna work. Not sure what I want to try hit it with for just like a quick check that it's not immediately going to face plant. I guess we'll just go Y-Cruncher. Actually, I can check if it'll load up my memory, because I'm pretty sure that's the board like blocking access to the memory sensors. And yep, it's the board. Well, that's annoying. Anyway, so obviously the next thing I'm going to be testing on this board is some A-die memory. Because, yeah, this is 24 gigabit M-die. Oh, I guess I could have also swapped the TRP and TRAS around, but oh well, too late. But yeah, anyway, so that's kind of the main point, is just like the Taichi is capable of DDR5-8000. And at least on the BIOS version that I'm currently using. And yeah, hopefully you found this somewhat interesting, if not or useful. Yeah, so a big thank you to G.skill for the memory kit. I will be testing this memory kit on some other boards as well in the future. And where's the system specs? Yeah. So thank you to G.skill for the memory kit. Big thank you to the channel supporters for funding the purchase of the motherboard. And that's it. So thanks for watching, and if you'd like to support the channel, there's links in the description that you could check out. That would be very much appreciated. And man, it feels weird to be ending a video this quickly, but yeah, I guess that's it. So thanks for watching, and goodbye.